Welcome to aminacademy.com. In material science and engineering, let us discuss about some atomic models. We have read about the existence of some elementary particles that are more fundamental than chemical elements. That is, electrons, for example, are common to all elements and form a common building block of all matter. In order to have a clear picture of the extranuclear electronic structure, mainly with the help of positive rays and mass spectroscopy, several atomic models about atomic structure have been advanced over the years after obtaining quantitative measurements on electrons and positive rays. Now we shall now discuss some of the important atomic models proposed by Sir J. Thomson, Rutherford, Niels Bohr, Sommerfeld, and modern atomic models. In that, first we'll discuss about Thomson atomic model. Thomson atomic models, there is two important postulates are there. First one, an atom consists of a positively charged sphere with electrons embedded in it, like plum pudding. An atom as a whole is electronically neutral because the negative and opposite charges are equal in magnitude. Thomson's atomic model is compared to watermelon, where we consider watermelon seeds as negatively charged particles, the red part of the watermelon as a positively charged. Thomson's model is consists of that in all matters, the electron is a constituent of all matters. The electron has a negative charge of 1.602 into 10 raised to minus 19 coulomb and rest mass is 9.1085 into 10 raised to minus 31 kg. The electron has a negative charge. Atoms are uniform sphere with which electrons were distributed along the positive charges like plums in a pudding. The electrons possess vibratory motion about their equilibrium position and cause emissions of light. Thomson, by using various methods of spectroscopy, also computed the total number of electrons in an atom. Thomson's proof for the existence of electrons in an atom was a major achievement and an essential prerequisite for the subsequent theories of atomic structure. By using different materials for the filament wire, Thomson established that the same value is always obtained for the charge of mass, that is E by M ratio of the electron. This clearly supports the statement that the electron is a constituent of all matter. Thomson's model could account for the periodicity in elements, spectral lines, existence of ions, and kinetic theory of gases. Thomson's atomic model is compared to watermelon in that he says where he considered the watermelon seeds as negatively charged particles and red part of the watermelon as positively charged. We have already discussed. Now, limitation of Thomson's atomic model. It failed to explain the stability of an atom because his model of atom failed to explain how a positive charge holds the negatively charged electrons in an atom. That means holding force is not explained clearly. Therefore, this theory also failed to account for the position of the nucleus in an atom. Then, Thomson's model failed to explain the scattering of alpha particles by thin metal foils. No experimental evidence in its support. Although Thomson's model was not an accurate model to account for the atomic structure, it proved to be the base of the development of other atomic models. Find the atomic structure. The study of the atom and its structure has paved the way for numerous inventions that have played a significant role in the development of humankind. Therefore, Thomson's model is failed. Next, we will discuss next Rutherford's nuclear atomic model. Rutherford's model proposed that the negatively charged electrons surround the nucleus of an atom. He also claimed that the electron surrounds the nucleus revolves around it with very high speed in circular paths. He named these circular paths or orbits. Rutherford and co-workers in 1911 performed differential scattering experiments and proposed a new atomic model. Rutherford directed alpha particles emitted from a radioactive source on the thin gold foil around 4 into 10 power minus 6 meter thick. He observed that some alpha particles passed through the film while others were scattered all around. Some alpha particles pass through, most of them is come back with angular elevation. Those alpha particles passing through the thin gold film also scattered over a wide area and produced luminescence of on a fluorescent screen of zinc sulfide. Very small number of alpha particles were deflected through large angles. Here we will discuss further about observation of Rutherford alpha scattering experiment. The observation of Rutherford's alpha scattering experiments are: first, he observed that most of the alpha particles are bombarded towards the gold sheet pass away the foil without any deflection, and hence it shows that most of the space is empty. Means most of the alpha particle pass through gold foil. That means most of the space in gold foil is empty. That means most of the atomic space is empty because alpha particle have positive charge. It won't deflect or attracted with some other particle. So it's go through. Out of all, some of alpha particles were deflected through the gold sheet by very small angles, and hence it shows the positive charge in an atom is non-uniformly distributed. The positive charge is concentrated in a very small volume in an atom. Some is deflected. Very few of the alpha particles, nearly 1 to 2%, were deflected back. That is, only a very less amount of alpha particles had nearly 180 degrees angle of deflection. That means come back exactly back the same angle with 180 degrees. Angle of deflection. This shows that the volume occupied by the positively charged particle is very small as compared to the total volume of an atom. Now, from the alpha scattering experiment, Rutherford proposed an atomic structure of elements. On the basis of this experiment, that model says the positively charged particles was concentrated in extremely small volume, and most of the mass of an atom was also in that volume. He called this as a nucleus of an atom. Most concentrated area is a nucleus. Rutherford proposed that there is a negatively charged electrons around the nucleus of an atom. The electrons surrounding the nucleus revolves around it in a circular path with very high speed. He named these orbits to this circular path. Nucleus being a densely concentrated mass of positively charged particles and electrons being negatively charged and are held together by a strong force of attraction called electrostatic force of attraction. This beam of alpha particles, something's deflected, more pass through the gold foil. Now, Rutherford atomic model have some limitations. According to the Maxwell, an electron revolving around the nucleus should emit electromagnetic radiation due to accelerated charged particles emit electromagnetic radiation, but Rutherford's model sees the electrons revolve around the nucleus in fixed path called orbits. The radiation would carry energy from the motion which led to the shrinking of orbit. Ultimately, electrons would collapse inside the nucleus, but it not happen really. As per the Rutherford model, calculations have shown that the electron would collapse in the nucleus in less than 10 to 8 seconds. But it's not really happened. So Rutherford model has created a high contradiction with Maxwell's theory of, and Rutherford's later could not explain the stability of an atom. It could not explain the stability of atom. Rutherford also did not describe the arrangements of electrons in the orbit as one of the other drawbacks of this model. That means he could not explain how the orbits of the atom for the electron. Regardless of seeing the early atomic models were inaccurate and failed to explain certain experimental results, they were the base of the future of development in the world of quantum mechanics. So far we discussed about atomic model as Thomson atomic model and Rutherford atomic model. In further models we'll discuss in later videos. We have done. Please subscribe our YouTube channel.